Hi everyone, this is Sean. So I'm making up this video to show you how to build a simple model using ANSYS, and this is the model we want to build. Basically like a door frame shape with five nodes and 4 beam elements, and what we want is the horizontal beams and the vertical beams should be in different cross sections, and we want to have a force later on applied on this node on the beam. And sorry, that's the out of plane, which is in z direction force. And then we want to do some harmonic analysis and force response analysis. So that's what we're gonna do. So when you start workbench, you'll go into this new project screen, and on the left hand side there's a list of available models that you can use in your project, and on the right hand side, which is the main body, is your project itself. So to add a model, just simply drag what you want into your project. So the first step is we want to get a model analysis where we can get natural frequencies and mode shapes. So we just drag that in. So when you have a model in your project, you're going to have a few steps, and all you need to do is just follow the steps and make all of them just as a tick. Basically means you've done that. So the engineering data is already finished for you, so it gives you some basic material settings like steel, and what we use is steel, so we don't have to do that. So we just jump into geometries. In geometries, we're gonna define our model. So basically define the shape you have. So basically define this shape. So the first step is to import your points, to have your points. So points are here. So just click there. We have the points item. In one point item we can have multiple points. So I find the easiest way is to have a predefined coordinate data file, which is this one I've already written here. So the format is, the first column is the group number. We only have one group, so just one. The second column is the ID. The point IDs are 1, 2, 3, 4, 5. And then the last three columns are X, Y, Z. Note my column coordinates are slightly different to what you're gonna do, so just in case you want to copy my results. Alright, so just select your points and OK, and then each of step you want to generate, so you can show it in your screen, and you can obviously change the angle, the viewing angle to a bit. So then the next step is to create some lines where you can then build your beams on. So it's just concept and line from points. Then you just need to drag a line. Are we in the right? So you just need to drag your line to create a line and apply, and then generate, then create another line and generate. For each of the line, you have to, because later on we're gonna define different materials, different cross sections for these lines. So here we just need to frozen or freeze them. So that they don't join to a single beam element later on. So add frozen, generate. Alright, so in that way we see we have created three lines, line 1, 2, 3, but it automatically creates three paths, which are line bodies 1, 2, 3. You can see they've been highlighted, but they need to define a cross section, which we haven't got that yet. So we want to define our cross section. So it's just cross sections, I session. So we want this one, we can call them top. So the top beams, and these top beams, we just leave these defaults. Of course, yours gonna be slightly different. I'll just save time. So this one, I just say side beams, and I'll just change them slightly. Alright, just make them slightly bigger. And then what we can do is we can assign this cross section. So the side beams should be the side beams again, and should be side, and that top beam, we want it top. Alright, so now what we wanna do is we wanna join the whole thing into one part, so that they don't, when later on in simulation, they don't fall apart. So we select them all, and we choose to form a new part. So when you form a new part, it's a one part. You see the one part with three bodies, because later on we don't want these joints be separated. So we want to create a one part. And and another thing that's important is, if I switch to 3D view, and we can turn on the cross-section solid. That will show you what your I-beam looks like. So what you see from here is your beam is sitting, is lying down, which is not right. We want to sit straight up. So what we can do is, again, in here there's a option of selection tools. So this is if you want to select nodes. This is if you want to select an edge or a line. This is if you want to select a face, and this is the bodies. So now we want to select edge or a line. So we want this I-beam to sit straight up. So there is a cross-section alignment. If we don't do anything, it will be aligned to Z axis, but we don't want to do that. We want to align it to this beam, so we want to sit straight up. So if so you can see now this is sitting up, and we just do the same thing for this one. I'll do the same thing for these ones, and of course the same for this one. Alright, so now the beams are sitting in the right direction, and we're pretty much done for this, and we just generate everything and we can close it. Alright, then the second step, you see our geometry, you got a tick. The second step is do the model. Just double click the model, and in the model there's a few things we want to do. The first thing is we want to define the mesh, right? So in here we got mesh, so just click that. There's a mesh control, so we want to define the mesh by giving a size, and we want to choose where we want to mesh. So now we want to choose edges, and just hold your control key to do multiple choices and apply. So we want to do the mesh for all the edges. So the mesh size, we want to start with something big, so we'll some coarse mesh, for example 1 or 2 meters. Alright, so we got roughly 4 elements on each beam, and then then we need to define the boundary conditions in this step. So just by clicking the model can fixed support. There's other type of supports. So we want to fix. So now we want to fix a node, not an edge. So we go to the node, and again hold your control key to make multiple choices, and apply. Alright, so our support has been fixed. Then the next one is we want to tell ANSYS what we want. So what we want is analysis settings, and we want modes, right? So how many modes we want? Maybe 8. And in solutions, what we want to plot is a deformation. So we have a total deformation, and in total deformation we want all the modes being plotted. Alright, we're pretty much all set, and we can go solve. We just quickly solve. Alright, so that's the result. From this graph, you see we have find 8 natural frequencies, 1, 2, 3, 4, 5, and the frequency in hertz is plotted in this table. To see the mode shape, you just need to click each of the mode and retrieve this result. So this gives you a mode shape, and to give you a bit better plot, you can see the mode shape is actually that way. If there's animation, you can plot. So that's the vibration mode shape. If it's actually an out of plane mode. Another thing you can do is we call scaling factor. So now we use 10, but we can make it bigger. So the animation gonna be have bigger deflection, so sometimes to give you a clearer view. Another mode we see is still an out of plane mode, and the third mode again is still an out of plane mode, and the fourth mode, this is an in-plane mode. So if you look at X, it doesn't move. So it's if we look at that way, it's moving that. So it's an in-plane mode. And the fifth mode, this is too much. So again, this is an in-plane mode. Sorry, this is the out of plane mode. So it's doing that. And the sixth mode, it's again an out of plane mode. So the seventh mode, this is a seventh mode. It's a expansion mode or torsional mode. For the being, it's a combination of torsional and expansion. And your eighth mode, I think it's similar. Yep. I think for this case we haven't really found our second in-plane mode. This may be a higher mode. Let's try again. So in here we just solve 10 modes, and so we solve it again. Alright, so let's see our ninth mode. Okay, now we find our second out of plane mode. It's actually the 12th mode. Sorry, it's actually the 11th mode. So doing that, if you see that index, it doesn't go auto plane. So that's the two modes we can actually calculate analytically, and you should be able to compare those frequencies. And then the last thing we can do is, remember we did a fairly coarse mesh, so if we refine our mesh to 0.5 and we update, you see our mesh is much better now. And we solve it again. Again, if we look at our 11th mode, you can see the natural frequency is slightly changed, and of course the geometry become much smoother. And if we have our 4th mode, it's also become much smoother. I think so. That's our mode shape and natural frequencies analysis. And the next video I'm going to show you the harmonic analysis. Thanks.